All right, today we are doing section 3.2. It's all about rate of change. So our goal is to calculate rate of change given x and y values. So first we need a definition for rate of change. So give me 1 second, I'll get it up there. Here we go. Rate of change shows the relationship between two changing quantities. The quantities we're looking at today are x and y quantities. So this is how you're going to This is how you're going to find the rate of change. So the rate of change, we put the y's on top. That's kind of the tricky part. Remember, y's always go on top. We're writing the change in the y values on top of the change in the x values. So remember, y is on top, x is on the bottom. How do you find the change? What math operation gives us change? Some people call it the difference. What is that? Subtraction. So you're actually going to subtract your y's on top. You're going to subtract your x's on the bottom. That will give you your rate of change. All right, so the first thing you want to do in your notes is copy these down just how you see them. Now, the directions are very important here. It says determine if the data has a constant rate of change. Constant rate of change means that the rate of change stays the same. It's constant. It's the same. So what we're going to do is we're going to find the rate of change in between two ordered pairs. And then two ordered pairs, and then two ordered pairs, and then two ordered pairs, until we compare the whole chart that you're given. If the rate of change is the same the whole time, we're going to say yes, and then tell what that rate of change is. If you find that the rate of change is not the same, then you can simply put no and move on to the next problem, okay? Remember, rate of change is the change in the y values on top of the change in the x values. So I'm going to subtract these two y values first. What is 10 minus 4? 6. On the bottom of that, I'm going to put the x values. What is 2 minus 0? 2. Now, you can reduce that using your calculator. If you put 6, A, B, C, 2, it will tell you 3. I'm going to write it as 3 over 1 because I want to see exactly what the x value is on the bottom. I don't want to just forget about it, okay? So the change in the x is a 1. The change in the y is a 3. So we have 3 over 1. If you would just put 3, I would not mark it wrong, but anytime I do it, I'm going to keep it as a fraction. All right, now we do the next one. So what is 13 minus 10? 3. What is 3 minus 2? 1. I gave it away. So far, do you see how the rate of change is the same both times? If it's the same every time we do it, then we have a constant rate of change. So let's keep going. What is 22 minus 13? You guys have calculators. What's 22 minus 13? 9. Good. And what is 6 minus 3? 3. And 9 over 3 reduces to 3 over 1. And the last one here, we're going to do 25 minus 22. What is that? 3. And here we're going to do 7 minus 6, which is 1. So do you see we have 3 over 1, 3 over 1, 3 over 1, 3 over 1? Mm-hmm. So is the rate of change constant?
So you do 22 times 13?
22 minus 13. Oh. You're subtracting on each of these. 1, subtract the one right in front of it, subtract the one right in front of it. So, as I was saying, is the rate of change constant? Yes. And what is the rate of change? 3 over 1. Good. That is how you do these problems. What are your questions? All right, let's jump into number 2. I'm going to start again with my y's. What is 15 minus 8? 7. Good. And what is 4 minus 3? 1. So I'm hoping to get 7 over 1 each time. If I don't, I can stop and just say no, not a constant rate of change. What is 24 minus 15? 9. What is 5 minus 4? 1. Is this a constant rate of change? No. As soon as you see that they're not the same, you can simply put no and move on to the next problem. The only time you have to do all of them is when you think it's a yes, because you got to check them all. We're going to start number 3 by subtracting our y's. What is 5 minus 7?
5 minus 7 is 2.
Negative 2. On the bottom, we have negative 2 minus negative 4. That's like negative 2 plus 4, which is positive 2. You can reduce that using your calculator. You'll have negative 1 over 1, or you could just write it as negative 1. That would be fine with me. Again, the ABC button is what you're going to use to reduce. Alright, now if I'm going to get negative 1 over 1 on the next one, I'm going to keep going and see if they're all negative 1 over 1. If I find even one single pair that doesn't give me that, I can write a no and move on to the next question. What is 1 minus 5? Negative 4. What is 0 minus negative 2? It's actually a positive 2 minus a negative is like a plus. 0 plus 2 is 2. Is that going to reduce to negative 1 over 1? No. I can see right away that this is not going to be a constant rate of change. That actually reduces to negative 2 over 1. Once you see that it's a no, just write no. What are your questions? All right, here's number 4. I'll give you a second to get this one down. All right, so where should I start on this one? The 2 and the 3. What is 2 minus 3? Negative 1. And then on the bottom, what is negative 2 minus negative 4? Positive 2. So if I get negative 1 over 2 for the rest of these, then I'm in good shape. Okay? What is 1 minus 2? Negative 1. What is 0 minus negative 2? Positive 2. So far, so good, right? What is 0 minus 1? What is 2 minus 0? 2. Okay. What is negative 1 minus 0?
Negative 1.
And what is 4 minus 2? 2. Is this a constant rate of change?
Yes. I like how you try to call
And what is the constant rate of change?
1 over 2, negative 1 over 2.
Very good. And thank you. I think it looks nice in multicolors as well. It's like a nice pretty math rainbow. Any questions? Okay, the last example in the notes, I am not requiring you to write it down, okay? So you can just hang out and watch on number 5, but please remain quiet. Number 5 has lots of parts. The first thing it says is determine if the rate of change is constant. So that's what we've been doing. Here's the new part. Graph the data. After we find the rate of change, we're going to graph the data, and then we're going to see what the graph looks like. For the third time, no, you don't need to write this down. Okay, so I'm going to find the rate of change. What is negative 3 minus negative 5? Positive 2? 0 minus negative 2 is also a positive 2, so that reduces to 1 over 1. I'm going to do the next one now. Negative 2 minus negative 3, that's like negative 2 plus 3, which is 1. And 1 minus 0 is also 1. Thank you. Next, we have 1 minus a negative 2. That's like 1 plus 2, that's 3. And 4 minus 1 is also 3, which again will reduce to 1 over 1. And the same thing happens on the last one. We get 4 minus 1, that's 3. 7 minus 4, that's also 3, which would reduce to 1 over 1. So do you guys agree that there is a constant rate of change here?
Yes.
And that rate of change is 1 over 1. So that's the first part of the problem. I'm going to clean up my workspace a little bit. Do you guys have questions? Okay. Now, do you see how the first row says X and the second row says Y? You can actually think of these as ordered pairs. So like you could write this as negative 2, negative 5 like we saw yesterday. And 0, negative 3 like yesterday. And 1, negative 2 like yesterday. So this is the same as writing it in an XY table. Okay? So I am going to first graph negative 2, negative 5. Then I'm going to graph 0, negative 3. So side to side, 0, down 3. Then I'm going to graph 1, negative 2. So right 1, down 2. Then 4, 1. 1, 2, 3, 4, up 1. And then right 7, up 4. Now, I am supposed to find out or answer what type of graph do I get when I have a constant rate of change. So what does this graph look like? Would it help if I connected them? What is that a graph of?
A straight line.
A straight line. If you have a constant rate of change, your graph is going to be a line. You need to know that for your homework. Any questions? So on your homework, the last 6 questions look like this. The directions say determine which graph represents examples that have a constant rate of change. We just said that graphs with a constant rate of change form a straight line. Is number 9 a line? Yes, so that has a constant rate of change. Is number 10 a line? No, so that does not have a constant rate of change. Number 11? Yes. Number 12? No. 13? Yes. And yes, good. So again, this comes right from number 5 in your notes. If you are graphing data with a constant rate of change, you're going to get a straight line. Any questions? The rest of this worksheet you should be able to do. You have the rest of class to finish it. If you don't get it done, it is homework and due tomorrow.